they tell you the starting point and they tell you where to start approximating in these problems. Um, so it does help visually for it to make sense, like for your answer to make sense, but it's not necessary. Um, and then it says to get the approximation, use the formula, which we will talk about. Um, so I guess let me write down this first problem and then we can talk more about the formula. So our first problem, they want us to use Newton's method. This is just the first problem. They want us to use Newton's method on this equation, x squared plus x minus 1. And they want us to use xo, or x0, x naught is equal to negative 1 for the left side of the function. And then they want us to use xo equals positive 1 for the right side of f of x. And then the goal is to approximate or find, approximate slash find x2. So before we even start the problem, something that you should kind of do whenever you start, I think a couple more people have joined, so use the attendance link one more time. We're working on the first problem of Newton's method, and we're about to talk about a really important formula that you will have to know on this exam. So we're given this formula. X to the n, x sub n plus 1 is equal to x of n minus f of xn over f prime of xn, right? And it looks kind of nasty with all those n's, but it'll look a ton better whenever we substitute a value in for n. So let's just start with n equals 0, right? Let's see what the function looks like, or this formula looks like with n equals 0. So wherever we see an n, we're just going to plug in 0. So we have x0 plus 1 is equal to x0 minus f of x0 over f prime of x0. So we end up with x1 is equal to x0 minus f of x0 over f prime of x0. All right, so let's circle this because we will need this. And then let's see what this green function looks like with n is equal to 1. So we're going to have x1 plus 1 is equal to x1 minus f of x1 over f prime of x1. So it's going to be x2 is equal to x1 minus f of x1 over f prime of x1. Do you guys see any similarities? Is optimization really hard? I honestly, I wouldn't say it's like super, super hard. I would say that certain people's brains are better at it than others. Like people, like if you're like going to be like an engineer or an economist, like you would use optimization for like the amount of materials you're using, or like to optimize like, I don't know, like supply and demand, like stuff like that. There's various things that those people use optimization for, but and there's also like famous math problems that use optimization as well, but it's just not something I'm particularly good at, and I was not confident in talking about it without at least having like a review with Dr. Norm, you know what I mean? And I do feel bad for you guys because you guys have never even learned optimization. So if it's hard for me, it's probably very hard for you. But I think with enough videos and maybe some practice problems, it can start to make sense to you guys.
Can I see?
Yeah, Stephanie, you're right. So we see that we have a 1 on this side, and then everything on this right side is 0. And on the next one, we see that we have a 2 right there, and then everything on this right-hand side is going to be a 1. So these two different ones look exactly the same, but um, we're using a value that we already know, right? So in this problem, we see that we're given two different xos, or x naughts. I guess we'll just circle them like that. So when we have n equal to 0, we can find x sub 1 because we already know x0, and then we can plug x0 into our f of x and f prime of x. So Newton's method is basically just using the different forms of these functions in order to get a closer and closer approximation. So that's kind of the whole goal of Newton's method. It's also very similar to how a lot of computer programs approximate numbers. And the reason why is because after a couple iterations, meaning like, so we start at x1, x2, and then if we keep going on to x3, x4, x5, by the time we're at x4 or 5, we have an extremely, extremely close approximation. So that's primarily why we're learning it. It's a really cool and relatively easy method. I say relatively easy, but sometimes the functions can get a little complicated. And the whole process of it is having to do with tangent lines, using that derivative and tangent lines in order to approximate closer and closer. So I guess that's the whole goal, and I wanted to talk about that a little bit so you understand kind of why we're doing this. Does that make sense? I don't want to talk about this too much. I mean, I do, but I don't want to. I want to make sure that you understand that you are going to have to use this, and you are going to have to use this on the exam in order to find the approximation you're looking for. You're going to have to be able to plug in values of n and use these functions or these equations in order to approximate. All right, so after talking about that, we can go into actually starting the problem. So the first thing I really recommend you do is just take the derivative of f of x. So our step 1 is just to take, or I guess find f prime of x. Find f prime of x. So our f of x is x squared plus x minus 1. So what would our f prime of x be? Yeah, exactly. It's just going to be 2x plus 1. Right? That's not too bad. So we're done with that. And then our step 2, well, our step 2 would be to find these formula approximations, but we already talked about how you find them up here, so I'm just going to rewrite them down there. So we have x1 is equal to x naught minus f of x naught over f prime of x naught, and then we have x2 is equal to x1 minus f of x1 over f prime of x1. So that means first we're going to have to find x1 before we can find x2. And we know what our xo is, right? We know that xo is either going to be positive 1 or negative 1. Meaning that we are going to find two different values for x2. And we have to do this process twice. Does that make sense so far? how did we get the x1 and x2? Whenever we plugged in our different values for n, so we started, this function right here is Newton's method, right? This is Newton's method. So this is the formula you're going to have to know. But you're always going to start by plugging in n equals 0. And then you're going to write the function again with n equals 1. So wherever we see these n values, we're going to plug in 0. And so that's what we did right here. And then that's how we got this function right here. x1 is equal to xo minus f of xo divided by f prime. Yeah, we were given xo in the problem. Which, if you notice, is going to be... yeah, you see? Okay. Yeah, so they, at least in all the problems in the book, they give you x naught. So, generally, yes. If, let's say they gave you, like, the value for, like, x2 or something, instead, then you would plug in 2 for all of these problems. Does that make sense? So you would be finding x3 next. But yeah, in general, they're going to give you xo or x naught. And I guess that's a good way, I hadn't thought about that, but that's a good way to know what n you're going to plug in. You see that there's a 0 right there, so that's why we're plugging in n equals 0 first. And then after we find x1, then you see that we're plugging in n equals 1. And we know we're going to have to use the second formula because they're specifically asking us to find x2. I know this is kind of messy. I have it written a lot nicer on my sheet. Yeah, no problem. So sorry if it's a little messy on here, but yes. So then we just write down those two equations. I really recommend that you write down each iteration that you're going to have to do, just so you don't forget how many you have to do, because on the exam, he might ask you to go to x3 or x4. I doubt it, honestly, unless he only has one Newton method problem, but he'll probably ask you to go to x2, since that's what the book is doing. Yeah. I am planning on going through and working through the study guide. I will post them this weekend, but I'm probably also going to go over it on Tuesday. So I will post the answers early. I don't normally do that, but I'm doing that because some of you guys are taking it Monday, and I wouldn't have gotten time to cover it with you guys. But yes, I will probably also cover the problems on Tuesday for those of you taking it on Wednesday. So our step 3, you just want to use Newton's method, right, to find x2. Right. So we're going to start with xo equals -1. So I'm just going to write, because we have to do this twice, I'm going to write, sorry, let me use red, for xo equals -1. Alright, so I'm going to write down the formula that we just did so we don't mess anything up. Xo over f prime of xo. And also, I guess I'll just zoom out. We see that those are f of x and f prime of x. I guess I'll rewrite those right here. F of x equals x squared plus x minus 1. F prime of x equal to 2x plus 1. Alright, so we're just substituting all of xo's values into those equations. So, all I'm going to do is we're going to plug in -1 for xo. So we're going to have -1 there. Or I guess let me use black, so it's kind of hard to see. So we're going to have x1 is equal to -1 minus, and then in this equation, we're going to plug in everywhere where we're going to plug in -1 for everywhere we see an x. So we're going to have -1 squared minus, or plus -1 minus 1 over 2 times -1 plus 1. Does that make sense what I did there? So this yellow part is on the top is from f of x, and this pink part that's from f prime of x is on the bottom. And I'm just evaluating those different functions at -1.
I see.
You see it? It makes sense?
Mm-hmm.
Okay.
Mm-hmm.
Next problem I do, I'm not sure which way will make more sense to you. In this problem, I'm gonna evaluate it inside this part. Like I'm evaluating f of x naught and f prime of x naught inside, or Newton's method, but we can also do that outside and then plug it in, right? So we can do that next time and see if that makes more sense to some of you guys. All right, so we're going to simplify. So we have x1 is equal to -1 minus. And simplifying that top part, we have +1 minus 1 minus 1 over -2 plus 1. So x1 is going to equal -1 minus. And then we get -1 on top, and we have -1 on the bottom. So we have x1 equals -1 minus 1 equals -2. So our x1 is going to equal -2. Does that make sense? Awesome, awesome. All right, so now we're going to do this. We're going to find x2 for x1 equaling to -2, right? So we can write our equation. x2 is going to be equal to x1 minus f of x1 over f prime of x1. So again, we can write this, or I guess we just had our f of x up there. We shouldn't need to write it again. So just plugging everything in, we get x2 is going to equal to -2, because that's our value for x1, minus f of -2 over f prime -2. I guess let's just solve this outside, because it might make it a little less messy. F of -2 is going to be -2 squared plus -2 minus 1. So that's going to be 4 minus 2, or it's going to be 4 minus 3 is going to be equal to 1. And then, so I guess we should just write that f of 2 is equal to 1. And then for f prime, I guess let me do it in a different color. And then for f prime of, sorry, I'm just trying to do it in a color that y'all can see. For f prime of -2, we get 2 times -2 plus 1. So it's going to be -4 plus 1, so -3. So f prime of -2 equals 3. So then for that yellow one, we're going to plug in +1. And then for that pink one, we're going to plug in -3, not +3, -3. So our x2 is going to equal -2 minus 1 over -3. See that those negatives are going to cancel out, so that we get x2 is going to equal to -2 plus 1/3. We can write that -2 as -6 over 3. Right, we just multiply 2 by 3 over 3 to get a common denominator. Plus 1/3. -6 over 3 plus 1/3 is going to equal -5/3. So that's our first value for x2. Right, so this is going to be one of our answers. Is everyone okay with this? The numbers were pretty clean in this problem, so hopefully the computation makes sense. It's not that bad. Yeah, it's just a lot of algebra and making sure that you keep track of the right numbers. It's a lot of repetition. Yeah. All right, so yes, if we have time, I think I have 4 of these problems. I don't know if we'll get to the last one or not, but the last one is a little rough. The homework was so hard. Yeah. I think I have number 7 as my last one. The one where it's like 3 minus x equals natural log of x. That one had a pretty ugly answer. Anyways. Yeah. So anyways, now we have to find it for the right side of the equation. So this whole part, I don't know if I can scroll up anymore, but this whole part up here was for the left side of the graph. Right, left side of the graph. Alright, so now we're going to do, and it tells you that you have to do it for both. You don't necessarily have to know that it's for the left and right side, but you just have to know you have to find 2 different values for x2. So now we're going to plug in xo is equal to +1, right? For xo equals +1. So just as a reminder, our f of x is equal to x squared plus x minus 1, and our f prime of x is equal to 2x plus 1. And then our Newton's method equation was x1 is equal to xo minus f of xo over f prime of xo. Alright, so plugging those in, we get x1 is going to equal to 1 minus 1 squared plus 1 minus 1, so that's where that f of x came in, divided by 2 times 1 plus 1, and that's where that f prime of x is. I don't know how you could fix that problem other than like using an online calculator. Obviously on the test, I don't think that he would count you wrong. Because I know in the homework there's a lot of decimals. I think he's going to try and give you one where it's going to end up as a fraction. I would think so, at least, knowing Dr. Norring. But if not, then he would just tell you to write the decimal to a certain place, like either like the 5th or 6th place, which your calculator should go to. Yeah. Yeah, so it's just, what are the odds of him throwing in more complex functions? I wouldn't expect anything with a natural log, honestly, because that was the last one I did, and that was really terrible. The algebra for it was really, really terrible. And it's really easy to miss a number if you do something wrong. So I would expect, I don't know. I honestly don't know what to expect, so I wouldn't want to say it much, but I would say that I think there will probably be more Newton's method problems than optimization. Probably. Just a feeling, because I know that he likes Newton's method, so. Anyways, simplifying that right side of the fraction, you get 1 plus 1 minus 1 equals positive 1. Then 2 plus 1 equals 3. So we have 1/3, we have 1 minus 1/3, which is just going to equal 2/3. So that is our x1. So now we're going to write for x1 is equal to 2/3. And I'm just doing this to keep track of where you are. I would really recommend, like, you could do this one iteration with both positive 1 and negative 1, but I also think it might be a little confusing I feel like it's just easier to go do one x0 value and then do the other, if there is two. So that's what I'm going to keep doing. So writing down the other equation, we have x2 is equal to x1 minus f of x1 over f prime of x1. Alright, so we know our x1 is 2/3. Alright, so let's calculate those outside, since we do have a fraction this time. So f of 2/3 is going to be 2/3 squared plus 2/3 minus 1. So f of 2/3 will be 4/9 plus, I'm going to multiply that 2/3 by 3/3 to get 6/9. Then I'm going to write that -1 as 9/9. So 6 plus 4 equals 10. 10 minus 9 is 1, so we get 1/9. And then for our f prime of x of 2/3, we will get 2 times 2/3 plus 1. So we'll get 4/3 plus 3/3, so 7/3. Alright, so that means we're going to plug in 1/9 for that f of x1, and then we're going to plug in 7/3 for that f prime of x1. So we'll have x2 is going to be equal to, x1 is 2/3, so we'll have 2/3 minus, our f of x1 was 1/9, so 1/9 divided by 7/3. Right, so we can just use our keep change flip and get 1/9 times 3/7. So we'll have x2 is equal to 2/3 minus 3/63. I mean, you could find a common denominator. But honestly, at this point, I just put it in my calculator and got 13/21. So our x2 would equal 13/21. So in conclusion, because they're asking us to find our two different values for x2, x2 is going to equal -5/3, and x2 is going to equal 13/21. I think a couple more people have joined, so here's the appendix link. So is there any questions on this so far? I really did try to break it down into like as simple as possible way to do this. So I hope I did accomplish that. Is there any questions on how we got these answers? That was a reoccurring question on the homework. So I think I do, so, um, let me think about this. So for x is equal, so 1 is plus or minus. So you're approximating the zeros for it, right? So it has to do with x2 plus x minus 1 equals 0. Is this even factorable? You could probably use the quadratic equation on it to get -1 and +1. Yeah, you would have to find it, you would probably have to use a quadratic equation, so -b, so -1 plus or minus the square root of b squared, so 1 squared minus 4ac, so 1, -1, all over 2a, so that would equal -1 plus or minus roots. Never mind, I guess. Well, I guess I'm not really sure for this one. I know for the next one, or not for the next one, but for the one after the next one, it makes sense to me. So we can skip to that one, but I'm not really sure for this one. So it'd be 1, it'd be root 5 over 2. So I'm not sure. Yeah, I will see if I can figure that out next time. Or over the weekend maybe. I think he'll probably give it to you if he's just evaluating you on Newton's method. Hopefully he gives it to you, because otherwise I'm gonna feel real bad. But anyways, I figured maybe you could figure it out by solving for the roots yourself, but I'm not sure. Do you want me to skip to? Let me skip to number 6, and then we can go back to 3 if we have time. Alright, so this one is number 6 from the back of the book. Yeah, this one is a little bit harder. I mean, do you want me to do the really, really complicated? It's not really, really complicated, but it's like, it just looks really ugly. Yes, do that one. Let's try it. Okay. Alright. I warned you guys. So it's asking us to approximate the solution to, yeah, his tests are generally harder than the practice exams, because he usually gives you the easiest version of the exams. So usually they're a tad bit harder. Solution to, sorry, let me write it how it's written. So the solution to 3 minus x equals natural log of x by using x naught is equal to 2. So they want us to find x sub 2. Alright, so they give us this equation. First thing that you want to do if you're not given an equation equal to 0 is you want to write it equal to 0. So we're going to find f prime of x by first, but in order to do that we have to actually set it equal to 0 and then let it equal f of x. So if we have 3 minus x equals natural log of x, then we would get natural log of x plus x minus 3 is equal to 0. And then we can just let f of x equal natural log of x plus x minus 3. Does that make sense, how we were able to just rearrange that problem? Sweet. And then we just find f prime of x. You know, derivative of natural log of x is 1 over x. You know, derivative of x is plus 1. Alright, so these are going to be our two functions that we're using in our approximation. And then we're given x naught is equal to 2. So like we talked about earlier, I guess I'll write down Newton's method, x sub n plus 1 is equal to xn minus f of xn over f prime of xn. So we have to find our, I guess this would be our step 2. Step 2, find the equations. I'm just going to write EQ. So find the equations that you need. So we know at n equals 0, we'll get x1 is equal to x0 minus f of x0 over f prime of x0. And then for n equals 1, we would get x2 is equal to x1 minus f of x1 over f prime of x1. All right, so we're first going to approximate x1, and they give us x naught is equal to 2, so we're going to use this. So this part is our step 3, actually using the equation, step 3. So we're going to say for x naught is equal to 2, and then we're going to rewrite our equation, x1 equals x naught minus f of x naught over f prime of x naught. We are then going to have, let me rewrite these, f of x equals natural log of x plus x minus 3, f prime of x equals 1 over x plus 1. So using those, we see that x1 is going to be equal to 2, because that's what our x naught is, minus, and then for our f of x naught, we're going to have natural log of 2 plus 2 minus 3 over 1/2 plus 1. So we're going to get x1 is equal to 2 minus natural log of 2 minus 1 over 3/2. So we get x1 is equal to 2 minus 2/3 natural log of 2 minus 1. x1 is going to equal to 2 minus 2/3 natural log of 2 minus 2/3. We can rewrite 2 as 6 over 3. Oh, I forgot to distribute that negative sign, so this is actually going to be positive. Yeah. That negative 2/3 went to the natural log of 2, and then it also went to the negative 1. So 2 plus 2/3, so it's going to be 6 over 3 plus 2 over 3. So we're going to get positive 8 over 3. And then if you remember our log rules, this is just personal preference. Can you not just solve it on the side? What do you mean, Emily? But anyways, I'm going to use our log properties to bring that 2 inside the parentheses, so we get 1/3 natural log of 2 squared, which is going to be 4. Yeah, you can absolutely do that. I think I did that on one of the problems earlier. And we will definitely do that for the second approximation for this problem. I probably should have done it here, but yeah, you can definitely do that. So I'm going to just factor out that 1/3 to get 1/3 parentheses 8 minus natural log of 4. So this is our approximation for x1, which already looks a lot uglier than the last problem, as you probably noticed. And I did approximate this. It's about 2.02046. You are not allowed to give a decimal approximation until you do the final one. Like, you can't approximate before you do your final iteration, if that makes sense. So you have to get it to this form, not exactly that form, but something that's equivalent and exact. Like, you could have kept it like that and you would have been fine. I mean, you could have even kept it like this if you wanted to, but it would look a little, I mean, you would need to combine these two. And Gabriel, we got the 8/3 by adding 2 to 2/3, so 2 plus 2/3 is equal to 6/3 plus 2/3 is equal to 8/3. How did we get the, sorry, my cat is in front of the screen. How did we get the 2 to the 2 again? So we have a log property that says ln of a to the b is equal to b ln of a. So I just brought that b back in that where that a is. I could have brought in that 1/3 as well, but since we had something nice to factor that out with, I didn't.
Oh, okay.
Does that make sense? And the 2/3 and 2. So Gabriel, we got the 2 because they gave us that in the problem. We started with x naught is equal to 2. And then we got the 3/2 by plugging into our f prime of x to get that right there. Does that make sense? Sweet. All right, so now we have our x1, but it's not very pretty looking, and I promise you that x2 is a lot less prettier than that. So now we're gonna find x2. So I guess I should say for x1 equals 1/3 8 minus ln 4. And you don't have to write this exactly. You could say finding x2 if that makes more sense to you. That probably makes more sense in retrospect, but that's just what I decided to write. So again, I'll write down our equation. Our x2 is equal to x1 minus f of x1 over f prime of x1. So writing out our f of x and our f prime of x, our f of x natural log of x plus x minus 3, f prime of x equals 1 over x plus 1. So let's solve for f of x1 and f prime of x1. So let's do a little bullet point, and then we have f of x1. It's going to equal f of 1/3 times 8 minus natural log of 4. So that is going to be equal to natural log of 1/3 times 8 minus natural log of 4 plus 1/3 times 8 minus natural log of 4 minus 3. We have another log property that's ln of A times B is equal to ln of A plus ln of B. And you see that 1/3 is being multiplied by that 8 minus natural log of 4. So I'm going to rewrite that as natural log of 1/3 plus natural log of 8 minus natural log of 4 plus, I'm going to distribute that 1/3. We get 8/3 minus 1/3 natural log of 4 minus 3. And we can add those two together, that 8/3 and that 3. So we're going to get natural log of 1/3 plus natural log of 8 minus natural log of 4. We know that -3, let me write this off to the side, -3 is going to be equal to -9/3. -9/3 plus 8/3 is -1/3. So we'll have -1/3 natural log of 4 minus 1/3. And so this is our f of x1 right there. It's not very pretty, but it's what we got. Let me just double check myself to make sure. Yeah, it's the same thing I got initially. Alright, so now let's do f prime of x1. So we have f prime of x1 is 1. So that's actually, sorry, it's going to be f prime 1/3. No problem, Emily. I will post the solutions to this in the group me, so, and you can always ask me if you have questions. No problem. Alright, so we have 1/3 times 8 minus natural log of 4. So that's going to equal 1/1/3 times 8 minus natural log of 4 plus 1. So we could do some algebra to this. Personally, I didn't do any algebra to this on my sheet. So I guess what we could do, I mean, do you guys want to do algebra to this? I really don't think it will make our problem look any better, even if we do, so that's why I kind of avoided it. Does that make sense? Like, if we, like, added those together, like, it would it would still look terrible. So, I really didn't bother to simplify it. And I think as long as, with Newton's method, as long as you have, like, the right thing written, and then you do your approximation, you're fine. Because after this iteration, like, can you imagine doing x3, like, after this? Like, that would be terrible. Alright, so our x2 is, I mean, like, if it was like the problem we did earlier, like the first problem, and you can simplify that easily, you should. But if it's something like this on the exam, like, I would not expect him to expect you to simplify that further, honestly. So our x2 is going to equal, so we have our x1, which is 1/3, 8 minus natural log of 4, minus our f of x1, which is natural log of 1/3, plus natural log of 8 minus natural log of 4, minus 1/3 natural log of 4, minus 1/3 over, in parentheses, 1/1/3 8 minus natural log of 4 plus 1. Okay. So I can't really zoom out anymore, but that is our x2 if we want an exact form. So it's pretty ugly. It's really ugly, actually. Not just a little bit, it's very ugly. But yeah, you plug that bad boy into your calculator. It'll probably take you like 30 seconds to a minute to input it. And then you should get x2 is approximately 2.20794. And you can approximate more digits if you want, but I didn't feel like writing more than that. Yeah. So, I mean, he probably wants both answers, but that's the reason why I was like, I don't think he'd use a natural log on the exam, because you would end up with natural logs inside natural logs, and it just is not super pretty. But yeah, it's really, but you see, like, even with problems like this that are harder algebraically, you're still doing the same process as we did on the easier problem, right? And we don't have enough time to do another one because each one of those problems took like 25 minutes, I think. Yeah, see you next week, Noah, no problem. But yeah, I am here for any questions. Yeah, once you memorize, yeah, because I mean, once you memorize the process, you're going to memorize these equations. Like, you just have to know that the left side is one more than the right side, right? I wrote x1 down there, that's not bxo. I honestly have no clue how he's going to structure this exam. Eleanor, you're not in the group me? Yeah, give me a second, and I'll grab you a link. Give me 1 second. And anyone else who's here who's not in the group me, please stick around for the link. Copy. There you go. I'm so sorry that you weren't in that earlier, but there you go. Yeah, you too, Amon. Have a great night.